So a lot of what this unit is going to be looking at angles in coordinate planes, like in the with the XY plane. So we're going to start drawing them in coordinate planes. So there's some terms and things I want to get used to as we do this. Um, so for starters, let's define initial and terminal sides. So the initial side is always going to be this positive x-axis. So when we're talking about angles in this unit, we're always going to know that one of the sides of the angle is on this at x equals or at y equals 0, like right along the x-axis. And then this is called the initial side. And then the terminal side is going to be one that goes who knows where. So in this case, we're looking for an angle that's 225 degrees. Well, I know a straight line, so over here would be 180, right? So it's going to be further than that. Um, this is going to be another 90 on top of 180, so that would be like 270 because this is a 90-degree angle, right? So that would be 270 going this way. That's 3 times 90. So that's too far. So we're looking at 45 degrees past 180. Well, that happens to be half of 90, so we actually know that this is going to be halfway between these two. And this is our terminal side. So putting definitions in for these, our standard or our initial side is the positive x-axis, always. And the terminal side is where the angle ends. And we're always going to start going counterclockwise. So you start at the initial side, you go counterclockwise this way. It's always going to be counterclockwise unless you're dealing with a negative angle. We'll talk about that later. That'll make the colors match. That's a little better. So now if we go back and look at this other problem, we've got 480 degrees is our angle. So let's talk about what coterminal angles are first, I think. So the definition of a coterminal angle, it's angles that end in the same place. Like you see, 480 is more than 360. It means we're going to go around the circle, not twice, but more than once. So if we started here, right, this would be 360, and then you just keep going for another 120 degrees, right? Because 480 equals 360 degrees plus 120 degrees. So 120 is going to be between 90 right here, it's a 90-degree angle, and 180. So it's going to be somewhere in between here, about 30 degrees past 90. So let's say it's that. Let's change the color though. And then the x-axis will be our initial side again. And then that one's going to be the terminal side. So going back down here for the definition of coterminal angles, that still might be a little unclear, right? But what we're looking at is if I drew 120 on this graph, it would be in the exact same place as 480. And that continues, right? If we added 360 again, that's just another circle around. You land in the same spot once again. And then 480 plus 360 is 840. So that would be another coterminal angle. So coterminal angles are angles that end in the same place. So to look at an example, angles that are coterminal with 150 degrees. Well, 150 degrees, let's use black, plus 360 degrees, that's just a circle around after 150, right? That's going to be equal to 510 degrees. And then we could do 510 degrees and add another 360 degrees, right? It's a coterminal angle. Adding another 360 just gives you another coterminal angle, and that's going to give you 870 degrees, and so on and so on. You can just keep doing that. Another way to do that, actually, we'll come back for this second way because we're going to learn about it first. But there's a general way to write. Actually, I'm going to leave the general form blank too until we get down here to negative angles. First, let's look at reference angles. So reference angle is the smaller angle made with the x-axis and the terminal side. So looking here, This is the x-axis, right? And then this is the terminal side. So the smaller angle there would be this one right here. And on this one, it would be this one right here. So those are going to be our reference angles. It just gives us an idea of how big this angle is. So let's put the definition in. So it's the smaller angle made with the x-axis and the terminal side. In this case, it's this angle right here. And in this case, it's this angle right here. It's always made with the x-axis and the terminal side. So then, and then it's also, because you could look and say, well, this is between the x-axis and the terminal side, right? That's not incorrect. So we also define it as being between 0 and 90 degrees. So it's always going to be the smaller of the two angles that's made with the x-axis and the terminal side. So it's between 0 and 90 degrees. So 0 degrees is less than or equal to theta, which is less than or equal to 90 degrees. And I'll mark theta is going to be our variable most of the time when we're working with sine and cosine. So now that we know that, let's go look at this just briefly, since we defined what the reference angles were. So this, let's actually figure out what they are, right? So this is 225 degrees, this whole angle. And we want to figure out what the pink angle is, right? So this is 225. The pink angle is everything past 180, right? Like this we know is 180, 180 degrees because it's a straight line. So that means we could just do 225 minus 180 degrees equals 45 degrees. So that means it's a 45 degree angle. And we kind of figured that out too when we were trying to figure out where to put it. We knew it was 45 degrees past 180. So looking at this one over here, instead of going past 180, we're not quite at 180. So we'll have to figure it out a little differently, right? Well, we do know that that this right here would be 540 if we're looking at this as 480, just so we can always use this number and we don't have to like figure stuff out, do extra steps. So we know that if this is 480, let's see, one circle around is 360, plus another 180 is going to be 540. So that's how I figured that out. So then this is going to be 540, 180 right here, minus this difference. So, or sorry, not minus this difference. We're trying to find this difference, so it's minus everything else. 540 minus the whole rest of that squiggle that I just did. So 540 degrees minus 480 degrees equals 60 degrees. And that's our reference angle there. Another way to do that is you could, since you know that this is the same as it's a coterminal angle with 120, and then this is 180, you could do 180 degrees minus 120 degrees. So that might be easier for you to conceptualize. Then you just need to know that this is 480 and 120 are the same. So now coming back down here, we're going to look at what happens when you have a negative angle, and then we'll be able to kind of go back and address those other problems. So negative angles just go in the opposite direction, like I mentioned, which means you start going clockwise instead of counterclockwise, like we did for the other ones. And if it's easier to think about than thinking about clockwise, counterclockwise, you can think about negative being start going down, and positive, you start going up. And then obviously that'll turn into clockwise or counterclockwise and clockwise. So if we look at this example over here, negative 260, we're just going to go negative 260 degrees this way. So that's negative 180. This would be negative 270, the same as 90. So we don't want to go all the way there, but we're going to go about 10 degrees shy of that. So if that's 10 degrees shy, then our reference angle would be like 80 degrees, right? This would be 80 and this would be 10. So that's going to be the terminal side, right? And then this right here is the initial side. And this is the reference angle, which is 80 degrees. And then I just want to go back and add the general form for coterminal angles and another example. So remember, coterminal angles are angles that share the same terminal side. And we were just adding 360 to these. So we were doing like one more loop and then one more loop, so on forever. And we're seeing that we can do that as many times as we want. But with negative angles, you can go in the other direction and you could still land on that same spot, right? Like here, instead of doing plus 360 more, I could do minus 360 and go backwards. And you could just keep doing that forever as well, because we just saw that you can plot negative angles. So for our example, where we had 150, instead of 150 plus 360, let's do 150 minus 360 degrees. And that equals negative 210 degrees. So then we know that negative 210 is also coterminal with 150, 510, 870. It's on that same path. And there's a way to write a general formula for that, which is, as we may have guessed, 150 degrees plus or minus 360 degrees times n. So that n means we can plug in any whole number. N has to be a whole number. Any integer. And that just means every 360 times 1 would be 1 circle, 360 times 2 would be 2 circles, and so on. So n can be any number, and that just tells you how many circles you're going around and returning to the same spot. So that's it for that, just kind of this new vocabulary that we're going to be working with, and we'll get a lot of practice with it. Feel free to reference this frequently.